So for this example, we are going to be determining a standard deviation. So it says consider the following set of data, and you can see the data set here. And letter A says assume the data is a population size and determine the standard deviation. And then B says assume the data set is a sample size and determine the standard deviation. We're going to come out with two different standard deviations because one represents a population and one represents a sample. So the first thing we want to do, step number one, I'm just going to write it right here, is whenever we look at a set of data, we want to determine if that set of data represents a population or if it represents a sample. And the reason we want to do that is that's going to set the pace as far as what our outcome is going to be. Now, of course, for A, it says let's just assume it's a population. So the first thing we're going to do, we're just going to assume that according to these instructions, that this data set is a set of data from a population. The next step, that's going to be step 2, is then find the mean for this set of data. So we'll do that. We'll go over to our calculators over here and we'll just go ahead and we'll find the mean. Of course, in order to find the mean, you add up all the data values and you divide by how many there are. So we'll do that. 14.7 plus 25.5 plus 21.9 minus, we have a negative there, minus 15.7 plus 44.12. We have another negative, minus 37.4 plus 29.46 and plus 18.03. We go ahead and hit enter. Then we have 1, 2, 3, 4, 5, 6, 7, 8 data values. So I'm just going to hit my division here. And when you do this operation, it automatically does it on the last answer. That's what this ANS stands for, and the last answer that had popped up. So we're going to be dividing the last answer that popped up. And again, we're going to divide it by 1, 2, 3, 4, 5, 6, 7, and 8. So we'll divide it by 8. Hit enter, and we have a mean of 12.5763. We're just going to round it to 4 decimals. 4 decimals is going to be plenty for the work we do. So I'm going to put it in right here. Now, since this is a population, a mean is labeled as mu. Mu is a lowercase Greek letter. And whenever we see mu, we know that that mean represents the mean of a population. So that's going to be mu is, and we'll just put down as approximately equal to 12.5763. Then we go to step 3. Step 3 now is we now start finding the deviations between an individual data value and its mean, the data set's mean, and then we square it. So we'll first put in 14.7, then we subtract the mean, 12.5763, and we square it. And of course, now we're going to go ahead and we'll put that in our calculator. And we can put it in just as we see it here. We have parentheses here. I'm going to use them. I have a squared key here. Certainly going to use that. So 14.7 minus 12.5763. We'll close off our parenthesis, square it, and hit enter. That's approximately 4.5101. And then we move on to our next value here. 25.5 minus 12.5 4.5763. And we square it. And I like to leave my values up here like this because it shows me exactly what I have to do. As you can see it right here, 14.7 minus 12.5763. I have it enclosed in parentheses and I square it. So I know the pattern that I have to put in. 25.5 minus 12.5763. Close off my parenthesis, square it, and hit enter. 167.022. And then I continue on with each one. So now that we have all the deviations squared in here, our next step, step 4, is we then sum it all up and divide by the population size, which is 8. 1, 2, 3, 4, 5, 6, 7, 8. So when I sum all this up, it comes out to be 4,865.4503. Again, we're going to be doing 4 decimals. That's going to be plenty. We'll then divide it by the size of the population, which is 8. This comes out to be approximately 608. Again, we'll do 4 decimals, 1813. Then the final step, step 5, is then to take the square root of this value. So we'll just square root it. So on the calculator, we could just go ahead and put in second square root. You can see the square root symbol right here. So second square root, and I'll type in 608.1813. So it comes out to be approximately 24.6613. So the standard deviation of this data, when it's considered a population, if we assume it's a population, it'll have a standard deviation, and we designate that standard deviation with sigma. Just like mu recognizes that this data represents a population, sigma is the symbol that recognizes that this is the standard deviation of a population. So that's 24.6613. Now for letter B, we have to assume the data is a sample size. Determine the standard deviation. So the process is almost identical. Step 1, determine what type of data set it is. Here it's telling us that it's a sample size. Step 2, we go ahead and find the mean. The mean is calculated the same way. We go ahead and add all these up and divide by how many there are. Except we label the mean for a sample as X bar. That's the symbol for a sample of the mean of a sample. That way we can distinguish it between if the mean is of a population. It's still the same value. It's still 12.5763. It's still calculated the exact same way, except this tells us that we're talking about a sample. This tells us that we're talking about a population. Step 3, we go ahead and we find out all the variances and then we square them, all the deviations and square them. That's the exact same thing here. That's exactly what we did. Step 4 then says sum them all up, which is our 4,865.4503. But this time we don't divide by 8. We don't divide by the population size. We divide by a degree of freedom, which is n minus 1. N is the size of the sample. If we assume that this is a sample, we have 1, 2, 3, 4, 5, 6, 7, 8. 8 minus 1, we wind up dividing by 7. That's the critical point of the difference between a population standard deviation and a sample standard deviation. So we divide by 7. It's approximately equal to 695, and again we'll use 4 decimals, 0.0643. Our final step, step number 5, is we then take the square root of this. So we'll do that. Again, back to our calculator, we go to second square root, 695.0643. Hit enter, and it's approximately 26.3641. So the standard deviation, if we were to assume that this data is a sample size, the standard deviation, it's labeled as S. That way we know that it's a standard deviation of a sample, and it's approximately equal to 26.3641. Now here is a tip. The standard deviation of a sample will always be larger than the standard deviation of a population, because a population uses all individuals. Therefore, it's dividing by a larger number. The result will be smaller. And there you go.